Now let's talk about false position. False position is another bracketing method that we've discussed, and we're going to use the same function and the same starting point as we did for bisection so that you can compare how they perform at least on this one problem. Now, in false position, the fact that the function evaluates at 0 and 1.5 at its particular values is important. The reason it's important is that we're going to use those two values to draw a line. We're then going to guess where that line intersects with the x-axis. In other words, where that line is equal to 0. In this case, it looks to my eye like that's roughly 0.6 or a little below. There, we can evaluate the function, and then we can use that first to guess which part of the bracket we can throw away. And the answer is we can throw away everything left of that because the sign change appears to be on the right part of the bracket. I can't say half anymore because we're not cutting this in half like we would in bisection. And then I can use this new function evaluation and the old bracket edge to draw another line. And that line will help me to choose a new point here. That point is roughly 0.7. And we'll notice that our function evaluation has gotten lower. We can repeat this process several times, each time choosing a point a little bit closer to the true root, which is 0.73. I do want to note that while we're getting closer, and we are getting closer significantly faster than did bisection. In fact, within 4 iterations, we're quite close. We're very near to 0.73. We're not seeing the bracket itself shrink in the same way, and that's because this is a fairly smooth function that never causes it to jump the guess to the other side. Instead, what we do see is we see it getting closer and closer to the root, and then it moves less and less because the function evaluations are getting so small that the 0 intercept is very, very close to the old guess.